Hello and welcome back to this video lecture on Chapter 3. Today we're going to begin with relationship-related terminology. And one thing I need to mention is that these relationships are between tables. And so that's how you associate records from one table to records in another table. Now, you don't have to combine the entire record from each, but you can pull out fields from one table that match the record in another table and only get partial fields out of that other matching record as well. So you want to establish a primary and foreign key relationship. If you're going to do the different types of relationships, that is, you can have one-to-one, one-to-many, or many-to-many. And if you have a many-to-many, you're going to need to have a linking table. And I'll show you how that works in a moment. But once you get the tables linked up, then you're allowed, or you can do multi-table queries. That is, you could have as many tables linked as you want, and you could pull different fields out of each matching record from each of those linked tables. And the whole purpose of having that data spread out among different tables is that you're going to reduce redundant data or duplicate data. And so, like I said, so the types of relationships here are one-to-one, one-to-many. One-to-many is the most common, and many-to-many is the one where you need that linking table to avoid some redundancy. Here we have an example of employees and compensation. So the employee table just contains information about the employee. Compensation is just about compensation. So the link here is between employee ID to employee ID. So one has a primary key, the other one has another primary key. Since this also acts as a foreign key, this compensation table, the employee ID field acts as a foreign key as well. Since none of this data can be repeated here, so I couldn't have another 100 employee ID record here with that primary key. So that's how we establish that one-to-one relationship. And it doesn't always have to be primary key to primary key, but it can be. Here we have an example of a one-to-many relationship. So again, here we're saying an agent can have many entertainers, and an entertainer can have one agent. So notice how I read that backwards. So it has to make sense when you're talking about it in both directions. So this is the primary key field in agents. Nothing can repeat here. That data can't be repeated. And then we have another field here, agent ID, where the data can repeat. So you have two 100s there. So this person, this entertainer, has this agent, and this entertainer has this agent. But an agent can have many entertainers, but an entertainer can only have one agent. So that's the most popular type of relationship. The third type of relationship is a many-to-many. So here we have one called students and classes. So a student can be in many classes, and a class can have many students. So that's the logical design. It would be linked up between student ID and something else. We don't have anything else here. So the way that's done typically is you have an intermediate or linking table. You combine the two primary keys from the two tables that have the many-to-many relationship, and then you use half of the composite key. Remember, a composite key is a key that's made up of more than one field to represent a primary key. And so in each instance here, half of that composite primary key represents a foreign key that allows me to link these tables. So now if I were to do a query and I say I want to know the first name and last name of everybody that's in class 90,003, this is how I would do that. I'd have to link these tables up and then I could pull that information. The next thing we want to talk about is the participation of each of the tables. There's actually two types. One is there's mandatory participation where data would have to exist into the linking table that it can match up with, or data can be entered and nothing has to exist in the linking table. And when that happens, that's called optional. So it's either mandatory or optional. I'll try and show you some better examples of this when we start talking about entity relationship diagrams again. But mandatory would be, I guess the example here would be if we've had students in classes, I shouldn't be able to enter a student in a class table unless they exist in the student table. So that student table is mandatory, but the class table is optional, meaning I could enter a student into the database, but I don't necessarily have to have them registered for any classes. So they may take off a semester. So I can leave them in that student table. And so that's what we mean by mandatory and optional. Now we've talked about the different relationships, but you could go ahead and specify the degree to which each table participates. So minimum and maximum records that you would specify that are associated with a single record in another table. Now, if we're using Access, we don't have that ability to specify that, but some other relational databases do. So you may think about, okay, if I want to implement this rule, how can I enforce that? So an example would be this last one here. A student can only be associated with 21 hours, so they can't take more than that. Once they hit that record, somehow the database should be able to aggregate how many classes and the hours that they're taking and then send a message back to the user of the database management system that they can't register for any more, or send out some kind of alert. The last thing we want to talk about in terms of terminology is integrity-related terminology. That is, ways to enforce that you're getting the correct data and accurate data into your database. And they fall into three different categories. There's general elements, physical elements, and logical elements. The general elements are the fundamental information about the names. So you might have, and remember this is about your field, so those columns that we're talking about. So the general elements would be the name, a description, what table do they belong to. The physical elements is, okay, I create this table. Now I've got to put in field names, and now I can give it a name and I can describe what it's used for and what table it goes with. Then I need to specify, okay, here I've got this name for this column and I'm going to be entering information into it. What kind of data type goes into it? How long can it be? What's the format of that? Is there anything I want to display to the user that might help them? So let's say you're collecting dates. You don't want to let people enter numbers for dates. You want to make sure that it's actually a date type so that that date goes into your database. You can specify how that's displayed on the screen when the user sees it. Maybe you want them to enter month, day, year in the United States, so you would give them a format on the screen for that. Maybe they need to be prompted for that. So those are all the physical elements of about that field specification that we're going to do. In Access, you're going to specify both the general elements and the physical elements all in one place, and also the logical elements are all in one place. So the logical element portion of the field specification describes the values stored in the field, whether it's required or not required. Remember, we talked about if you skip over that and it's not required, there's a chance somebody could put in a null. And the null means the absence of information. How is that going to affect your aggregate functions that you're going to pull out of your database? Also with that, you might have a range of values that are on the screen. You could also specify a default value. That's a value that pops up on the form when the user's entering information, and if they like that, they can just hit enter or tab, and that selects that default value to go into your database. You could also provide a list of values for them to choose from. So, let's say we had state and we chose the default value for state to be Kentucky, but they could hit the drop-down box and choose another state if they wanted to. So that's an example of a logical element of that field specification. The last thing we want to talk about is this concept of data integrity. You can think of it also as the validity, consistency, and accuracy of the data in your database. There's actually 4 types that we're going to move through. Those are table level integrity, field level integrity, relationship level integrity, and your business rules. So to ensure table level integrity, we're going to have a primary key, and we're going to make sure that primary key has a unique value and never can be null. So what this is really saying is that you can never enter a record into a table if it doesn't have a primary key. And the reason for doing this is if we allowed this to happen, there's no way we could link to this record and pull the information out. So that information would be meaningless unless we can get to it. So to ensure that integrity at the table level, we're going to have a primary key, and we're going to make sure no record ever gets entered into the table, into our database, without having a primary key. The second type of integrity is this field level integrity. Here we're going to make sure that every field is valid, consistent, and accurate. And the fields of the same type are defined consistently in the database. What that means is I might use the same data in different tables, and if I name that data something in one table, it should be named the same thing in another table. So the example here is city. I don't name it city in one table and town in another table and metropolitan area in another table. So when somebody's designing these databases and they're thinking about all the tables that are going to go into it, they're going to be consistent with the naming and description and use of that data in every table. And so when we start entering data in, we got to make sure that it's going to be valid, consistent, and accurate. It's going to be the same across all the tables. If it's not, we go looking for that data, we're going to get inconsistent information back out. So we want to avoid that. The next type of data integrity is the relationship level integrity. It's also referred to as referential integrity. And so that makes sure that the relationship between the two tables is sound and the records in the tables remain synchronized. So sometimes you can run into problems if you're designing a database and you remove that relationship and you add a record to one table, and that record requires a matching field in the parent table. If you try to reestablish that relationship, you're going to get an error because that matching record doesn't exist. If we enforce this referential integrity and never unpair them to add data in, that's what this is talking about here. we don't ever want to, once we've got the tables linked up, we don't ever want to allow part of the database management system to enter data into one table if the relationships aren't being enforced as we're doing it. The last type of data integrity here is the business rules. And this is where we can impose restrictions or limitations on the database and the type of data we're taking in. So that might include the range and types of values we have for a field, whether the field's required or not, and how much they're required. So that degree of participation, which we talked about earlier. And that ends this lecture for Chapter 3.